Hello students, today we will be solving the IB Math AHL May 2024 paper 1 time zone 2 question number 11. You will be getting the other solve past paper questions of this paper and of the other papers in form of playlist on my channel NS Online Math Tutoring Classes. You will also be getting playlists where the solve past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math AHL level tutor. In case you want to join my classes, please contact me for more details. My phone number and my website address are displayed at the bottom of the screen. So without any further delay, let us start solving this question. The maximum mark is 19. It says the plane pi1 has equation 2x plus 6y minus 2z equal to 5. Part A's question is verify that the point E with coordinates 2, half, 1 lies on the plane pi1. It is containing just a single mark. So plain and simple, we have to substitute 2 in place of x, half in place of y, and 1 in place of z. And we have to show that the left hand side's value, that is 2 times 2 plus 6 times half minus 2 times 1, is equal to 5. So, since 2 times 2 times 2 plus 6 times half plus or minus 2 times 1 is equal to 4 plus 3 minus 2 equal to 5. Therefore, the point E with coordinates 2, half and 1 lies on pi1. Okay. Coming to the part B's question before that, the plane pi2 is given by k square minus 6x plus 2k plus 3y plus pz equal to q. Pq and k are real numbers and p is not equal to 0. Part B's question is in the case where p equal to negative 6, pi2 is perpendicular to pi1 and E lies on pi2. Find the value of k and the value of q. It is containing 5 marks. Okay. So, the information, we are given many information, but one of them is pi2 is perpendicular to pi1 and the p's value is given. So, let me just rewrite the equation for pi2. Okay. It is k square minus 6x plus 2k plus 3y minus 6z equal to q, because p equal to negative 6. Okay. Now, since pi2 is perpendicular to pi1, therefore the normal vectors will also be perpendicular to each other. Okay. So, the vector normal to pi1 is equal to, I am naming it as n1, and this is equal to 2, 6 and minus 2. Okay. 2, 6 and minus 2. And the vector normal to pi2 is equal to n2 vector, which is equal to k square minus 6 and 2k plus 3 and p is minus 6. Okay. So, since pi1 1 is perpendicular to pi 2. Therefore, N1 should be perpendicular to N2. Okay. So the dot product should be equal to 0 because these two are two perpendicular vectors. Therefore, N1 dot N2 should be equal to 0. So, implies 2, 6, negative 2 dot k square minus 6, 2k plus 3 and minus 6 is equal to 0. And I have to expand. So, 2 times k square minus 6 plus 6 times 2k plus 3. We have to get the value of k. So, we will be getting the value of k from this equation. And plus negative 2 times negative 6 is plus 12 equal to 0. So, 2k square minus 12 plus 12k and plus 18 plus 12 equal to 0. And this plus 12 and this minus 12, they cancel and we have, I can write it over here, 2k square plus 12k plus 18 equal to 0. And I can divide the entire equation by 2 just to reduce the coefficients. So, it is k square plus 6k plus 9 equal to 0. And this is nothing but k plus 3 whole square. You can check. It is this 9 is 3 square and this 6 is 2 times 3. So, this is k plus 3 whole square equal to 0 or k equal to negative 3. K plus 3 whole square equal to 0 means k plus 3 is equal to 0 or k is equal to negative 3. Okay. And now we have to get the value of q as well. Okay. And we are seeing that A lies on pi 2. And the coordinates of the point A are 2, half and 1. Okay. So, A, 2, half and 1 lies on pi 2. So, therefore, the normal equation of a plane is n dot r equal to n dot a, where n is the normal vector normal to the plane, r is the position vector of any arbitrary point on the plane, and e is the position vector of a specific point which is on the plane. Okay. And we can get the n2 now because we need to get the value of q. So, first of all, let me write the n2 vector because we have now got the value of k. n2 is this one. Okay. Let me rewrite this first. n2 was k square minus 6 and 2k plus 3 and minus 6. So, this is equal to k is minus 3. So, minus 3 whole square minus 6 and 2 times minus 3 plus 3 and minus 6. So, minus 3 whole square is 9, 9 minus 6 is 3. And this is 2 times negative 3 is negative 6 plus 3 is negative 3 and minus 6. So, this is the n2 vector. And we know the coordinates of the E point which is lying on pi 2. So, its position vector I can write therefore n2 times position vector of A will be OA. Let me write this as position vector of A. This should be equal to 3 minus 3 and minus 6 dot 2 half and 1. Okay. So this is equal to 3 times 2 is 6 and minus 3 times half is minus 3 over 2 and minus 6 times 1 is minus 6. So these two will be getting cancelled and we have this as minus 3 over 2, or you can write this as negative 1.5. So this will be the value of Q. Okay, because it should be in dot A. In is the normal vector, normal to the plane pi 2, and E should be the position vector of a point lying on pi 2. I have taken the point as A. Okay, so this is the value of Q. You should be understanding the logic actually, because the topic vectors is scary for many students. But you see, if you just follow the logic, they have said E is lying on pi 2. And what is the normal equation? It is n dot r equal to n dot a. We have already got the K's value. So now we can get the n2. And this is this. So as soon as I'm getting n2 and I know this point A, I can get the value of Q, because n dot A will be equal to Q, the right hand side. Okay. For part C, D and E, it is now given that pi 2 is parallel to pi 1 and K is equal to 3. So part C's question is determine the value of P. P is now unknown. Okay. So again, let me write the equation of the pi 2, the plane pi 2. Okay. So it is K squared. So it is 3 square minus 6 x plus 2 times 3 plus 3 y and plus pz equal to q. Okay. So 3 square is 9, 9 minus 6 is 3. And this is 2 times 3 is 6, 6 plus 3 is 9. And plus pz is equal to q. Okay. So now, therefore, the n2, this is the equation of plane pi 2. So therefore, n2 is equal to 3, 9 and p. Okay. Since pi 1 is parallel to pi 2, it is written pi 2 is parallel to pi 1 or pi 1 is parallel to pi 2. Therefore, n1 should be parallel to n2. Okay, because the planes are parallel, their normals should also be parallel. Therefore, what is n1 from the first plane's equation? 2, 6 and minus 2. So, 2, 6 and minus 2. How do we write parallel vectors? One vector will be a scalar multiple of the second vector. Okay. So I can write this as, since I am having k, let me not take the k, let me take lambda. Okay. And this is 3, 9 and p. This is the n2 vector. So implies, if I read row by row, I'm taking the first row, it is 2 equal to 3 lambda. Therefore, lambda equal to 2 over 3. Okay. And also, minus 2 equal to lambda p. Therefore, p equal to negative 2 over lambda equal to negative 2 divided by 2 over 3 equal to negative 2 multiplied by 3 over 2 equal to minus 3. Okay. So determine the value of p. So the p's value is minus 3. Fine, we have got the 2 marks. It is also given that q is equal to negative 51 over 2. Okay, so let me write the pi 2's equation once more. Okay, so this is, it was 3x pi 2, 3x plus 9y, and p is negative 3, so minus 3z equal to q. Q is given as minus 51 over 2. So this is the plane 2's equation, plane pi 2's equation. The line through E that is perpendicular to pi 1 meets pi 2 at the point B. Okay. And pi 1 and pi 2 are parallel planes. So let me draw the planes. Okay, I'm taking this plane as pi 2 and this plane as pi 1 because I have seen the next subpart also. In case you do not know, you will obviously not be knowing what is there in the next subpart. So, but I'm not having any more space in the upward direction. That is why I have named this plane as pi 2 and named this one as pi 1. Okay. Or else I could have drawn the pi 2 below pi 1. And it is saying the line through E is in pi 1. So let me just take any arbitrary point. This A is on pi 1 and it is having the coordinates 2, half and 1, right? Yes. Okay. So a line perpendicular to pi 1 is meeting the pi 2 at the point B. Okay. So therefore the EB vector is perpendicular to both the planes pi 1 and pi 2. Because pi 1 and pi 2 are parallel planes, a vector or a line which will be perpendicular to pi 1 will also be perpendicular to plane pi 2. These two are parallel planes. So EB is perpendicular to pi 1 and EB is also perpendicular to pi 2. Okay. And what is the question? Subpart D, it is having two further subparts. It is the first subpart I is saying find the coordinates of the point B. The two subparts taken together is containing 7 marks. Okay. So this is the equation of the plane pi 2. And we are saying this is the line, they are saying the line through A perpendicular to pi 1. So there is this line AB. And what is the vector equation of a line? How can we get the vector equation of a line? What are the two things that are needed? Number 1, the coordinates of a point lying on the line. And number 2, the direction vector of the line. These are the only two things that are needed to get the vector equation of any line. From the vector equation, of course, you can get the parametric equations or the Cartesian equations. So you have to know the coordinates of a point lying on the line and the direction vector of the line. So we know that the point E is lying on this line EB, and we also know the direction vector of this EB because it can be taken as N1 or it can be taken as N2. Both are perpendicular to both the planes pi 1 and pi 2. Okay. So, but I do not want to take either of them. Let's see what can I do. See, N1 is equal to 2, 6 and minus 2. I can write this as 2. Of course, if you take this, you will not be wrong, or if you, in case you take this, it is 3, 9 and minus 3 in place of p, it will be minus 3. If you take this is the n2, you will not be wrong. But I am a little lazy, so I am taking 1 and then 3 and then minus 1. I will be taking this vector. This is also perpendicular. These two vectors will be parallel vectors. So definitely this vector will be perpendicular to both the planes. And what will be the difference? Only difference is the magnitude. Magnitude of this vector and this vector, they are not the same. The magnitude of this vector is double the magnitude of this one. So what? I need the direction. Okay. So I do not have to multiply with the 2's. I have taken 1. Okay. In case you want to take into, it will be the same case. You see, it is 3, 9 and minus 3. So if I take out 3, it is the same. 1, 3 and negative 1. So you can take 1, 3 and negative 1. But I am not saying that if you take this vector 2, 6 minus 2 or 3, 9 minus 3, you will be wrong. Or you will be getting some different answer. You will be getting exactly the same answer. But if you have 1 in place of some other number, the multiplication becomes a little easier. Okay. So this is the only reason for taking this 1, 3 minus 1 as the normal vector. So 1, 3 and negative 1 is a vector normal to both pi 1 and pi 2. Hence, it is the direction vector of AB or BA, whatever it is the direction vector of that. Okay. So therefore, and I know the coordinates of this point A, so I can get the vector equation of the line AB. Therefore, the vector equation of line AB is R equal to 2 half 1. This is the position vector of the point A. And I can take, say, T. And it will be, I'm taking 1, 3 and minus 1. Okay. Therefore, the coordinates of B will be 2 plus T will be the x coordinate. I am reading row by row. 2 plus T half plus 3T and 1 minus T. Okay. Since, and now I have to get the value of T. Otherwise, I cannot give the coordinates of point B. So, what should I be doing? I know that B is a point on this plane pi 2. So, I'll be substituting 2 plus T in place of x, 1 half plus 3T in place of y and 1 minus T in place of z and get the value of T. Only then can I give the coordinates, the numerical coordinates for the point B. Okay. So, there, since B lies on pi 2, therefore, 3 times 2 plus T plus 9 times half plus 3T minus 3, 1 minus T equal to negative 51 over 2. Okay. So, this is, I'm expanding 3 times 2 is 6 plus 3T, 9 over 2. 9 over 2 is 4.5 let me keep it as 9/2 plus 27t minus 3 plus 3t equal to negative 51/2. So 3t plus 27t is 30t plus 3t is equal to 33t equal to negative 51/2, and 6 minus 3 is 3 and 9/2 is 4.5. So 3 plus 4.5 is 7.5. Okay, if you are confused, let me show you. See, I'm just converting this 6 to 12/2. So 3 is 6/2 and 9/2. So it is 12/2 minus 6/2 plus 9/2. 12 minus 6 is 6. 6 plus 9 is 15. 15/2, which is 7.5. So it is plus 15/2. When taken to the other side, it is negative 15/2. Okay. So this is 33t equal to negative 66/2, which is equal to negative 33, implies t equal to negative 1. So now the b's coordinates will be, therefore b, 2 minus 1 is 1 and half plus 3 times negative 1. 3 times negative 1 is negative 3 plus half, so negative 2.5. So I can write negative 2.5 or I can write negative 5/2. And 1 minus t. T is minus 1, so minus t will be 1. So it is 1 plus 1 is 2. So these will be the coordinates of the point B, which is lying on the plane pi 2. Okay, this was actually the working of d, di. And now the I, hence show that the perpendicular distance between pi 1 and pi 2 is root 11. Okay, now we know I have not got the AB vector. If you have the AB vector, you can get its magnitude, or else since I'm not having the AB vector, I'll be using the distance formula to get the distance. Okay, I know the coordinates of the point B, I know the coordinates of the point A. So this is dii. Let me once more check the coordinates of the point A. It is 2, half and 1. And B, 1, negative 5/2 and 2. Therefore, using the distance formula, the distance between pi 1 and pi 2 is square root of x2 minus x1. Let me take this. So 2 minus 1 plus x2 minus x1 whole square plus y2 minus y1. So half minus of minus 5/2 is plus 5/2 whole square plus z2 minus z1. So it is 1 minus 2 whole square. So this is 2 minus 1, 1 square is 1. 5/2 plus half is 6/2, that is 3. 3 square is 9. And 1 minus 2 is minus 1. Minus 1 whole square is plus 1. Equal to root 11. Okay. So show that, so it is shown. Fine. Now coming to the last part E. find the equation of a third plane. That is what I was saying. Find the equation of a third plane, parallel plane, means parallel to pi 1 and pi 2, named pi 3, which is also having a perpendicular distance of root 11 from pi 1. It is containing 4 marks. We have to get the equation of the plane. In order to get the equation of the plane, what information do we need to have? We need to have the coordinates of one of the points on the plane, and we need to have the vector which is normal, which is perpendicular to the plane. These are the two information that we need to get the or write the equation of a plane. So first of all, let me draw over here. Okay, since I'll be solving the question over here, let me draw the 3 planes once more. So this is pi 2, this is pi 1, and this one is pi 3. Okay, so this is the point A with coordinates 2, half, and 1. This is the point, this is pi 1, this is pi 2, and this is pi 3. All of them are parallel planes. Okay, this is P, the point B rather, 1 minus 5 over 2 and 2. Okay, let me just, because I need the normal vector, this AB is, or BA, this vector is normal to both the planes, so it will be normal to pi 3 also. I'm just extending this and let this point be C on the plane pi 3. Okay, and this distance is root 11. We have to prove that, no, not prove, we know that the distance between pi 1 and pi 3 is also root 11, and we need to find the equation of the plane. We know the normal vector. The normal vector is known to us, but we need to know the coordinates of one of the points on the plane. Let the point be C with coordinates x, y, and z. Okay, so I have to get the coordinates x, y, and z's numerical value. Only then can I get the equation of this plane pi 3. So what can I do? The information that I can think of is, yes, of course, the magnitude is root 11. I can use the distance formula, but in that case, I'll be having 3 variables. I can take x minus 2 whole square, square root of x minus 2 whole square plus y minus half whole square plus z minus 1 whole square. That will be equal to square root of 11. Definitely true. But I'll be having a single equation but 3 variables. So I cannot solve. I cannot get the numerical values of these 3 variables. So I have to convert these into a single variable. I have to express this x, y, and z in terms of a single variable. I have to reduce the number of variables. Only then, if I use the distance formula, I can get the value of that variable, because I'll be having a single variable, single equation. I can get the value of that variable. So my first target should be to express these 3 variables in terms of a single variable. And how can I do that? I have only the normal vector. I know that AC will be normal, or AC will be, AC will be normal to the plane pi 1 or the plane pi 3. So it will be parallel to the normal vectors. This is what I know. So let me use that information. Okay. So AC is vector is x minus 2, y minus half, and z minus 1. Okay. So this is parallel to the normal vector that was 1, 3, and minus 1, right? So this is parallel to, let me take, say, S. You can take lambda, you can take mu, anything. 1, 3, and minus 1. 1, 3, and minus 1 is a vector which is perpendicular to the planes. So it will be parallel to the AC vector. And now I can get the XYZ in terms of this S. So I am reducing the number of variables. That is my only intention, because I can use the distance formula, but if I have 3 variables and 1 equation, I can never find the values of those 3 variables. So first of all, I have to reduce the number of variables, so I am using this. So therefore, x minus 2 is equal to S, implies x equal to 2 plus S. Y minus half is equal to 3S, implies y equal to half plus 3S, and z minus 1 is equal to minus S, implies z is equal to 1 minus S. Okay? So, now again I come to AC. Therefore, AC vector, now I will be expressing the AC vector in terms of S. So, and I'll be getting the magnitude of AC vector, which will be equal to root 11. Okay. So, in place of x, I'll be writing 2 plus S minus 2. In place of y, it is half plus 3S minus half. And in place of z, it is 1 minus S and minus 1. So these two cancel, and these two cancel. So this is equal to S, 3S and minus S. Okay. So therefore, the magnitude of the AC vector will be S square plus 3S whole square plus minus S whole square. This should be equal to square root of 11. Okay. Because AC vector is the vector line connecting the point A on the plane pi1 and the point C on the plane pi3. And the distance between these two planes is given as root 11. So I have formed this equation. So S square plus 3S whole square is 9S square plus S square. So 9 plus 1 is 11. So it is 11S square equal to root 11. So this is root 11S equal to root 11, implies S equal to 1. Okay. So therefore, the C's coordinates will be x equal to 2 plus x. Okay, these are the coordinates of C. So x equal to 2 plus S, S is 1. So 2 plus 1 is 3. And y equal to half plus 3 times S. 3 times 1 is 3, 3 plus half is 3.5. So it is 7 over 2. And this is 1 minus 1, which is 0. Okay. So now I have got the coordinates of a point lying on plane pi3, and I know the normal vector. Let n3 be equal to 1, 3 and negative 1. Okay. Therefore, the equation of pi3 is x plus 3y minus z, because x times 1 plus 3 times y and minus 1 times z. So x plus 3y minus z is equal to, this is n dot r, this left side, and the right side will be n dot a. So it is 1, 3, negative 1 dot, and the position vector of this point C. So 3, 7 over 2 and 0. Okay, so this is x plus 3y minus z equal to 1 times 3 is 3. 3 times 7 over 2 is 21 over 2. And minus 1 times 0 is 0. So this is x plus 3y minus z equal to 3. I am writing it as 6 over 2 plus 21 over 2, which is equal to 27 over 2. So therefore, x plus 3y minus z, x plus 3y minus z equal to 27 over 2. This is the equation of the plane pi 3. So this is the equation of the plane pi 3, okay? And most probably this was the last subpart. Yes, this is the last subpart. So we have solved this question completely. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation. And please subscribe to my YouTube channel in case you have not subscribed to my channel till now. Your liking, sharing and subscribing will be motivating me, will be helping me to get a better reach for my video, and the YouTube will be knowing that my videos are worth watching. So it will be helping me a lot. And in our next session, we meet very soon, and in our next session, we will be solving the last question of the same paper. Till then, bye.